Parallelogram. The thing about a rectangle that makes it special from other parallelograms is property number 1. That's what makes it a rectangle. All these other properties are just parallelogram properties. So all parallelograms have 2 through 4, but it's a rectangle only that has number 1. And so it has 4 right angles.
Miss, I do have a question, but
Opposite
absolutely
sides
not
are
about
congruent?
this.
Consecutive angles will add up to 180, right? Because 90 plus 90 equals 180. Opposite angles are congruent. 90 is congruent to 90. So it has all the same parallelogram properties. It's just that all the angles are 90 degrees. Oh, darn it. No, I don't want that. Stop. If a parallelogram is a rectangle, right? So we have a parallelogram. It's a rectangle, which means its 4 angles are all 90 degrees. Then that means that if you draw diagonals, the 2 diagonals are going to be congruent to each other. And if you think about it, it makes sense because this is a right triangle with 2 sides congruent to these 2 sides, which makes another right triangle. So it makes sense that the 2 diagonals would be the same. Okay, how do we use this? If you have a park that's a rectangle and it has 2 walking paths, PS is 180 meters. And PR, that's this diagonal, is 200 meters. We want to find QT. Okay, well, they gave me extra information. They'll do that to you. If I'm looking for QT,
Is that M for meters?
yeah. If I'm looking for QT, I don't really care what PS's length is, right? It doesn't have anything to do with each other. So this is extraneous information. But PR and QS they're congruent. So if PR is 200 meters, bless you, then QS is 200 meters. And it's a parallelogram, right? So the diagonals bisect. So QT is 1/2 of the whole thing of QS, right? Does that make sense? So QS is 200 meters, QT is 100 meters. So you have to look at the information they give you, and sometimes they give you information that's not valid or not necessary. Sorry, not that it's invalid, it's just not necessary, and in that case, you want to make sure. So we're using the same rectangle, same park. This is a park, looks like a park, right? It's a very pretty park. Anyway, if TS is 120, I want to know what PR is. Okay, well, QS is going to be 240. And PR is the same as QS, so that means PR will be also 240. Okay. Now for the angles. If I have the measure of angle PRS is 64, so PRS is 64. That's this one right. That's that one right there, 64. And I want to find the angle of SQR. That's this angle right here.
So what you have to do is just,
Well, these are 90-degree angles, right?
yeah, so you're gonna need to subtract 60. You gotta take 64 and subtract, and you ain't getting the answer.
90 minus 64 is 26. So this one's going to be 26. So is this one, and this one, and that one. So the measure of angle SQR will be 26. And then all the other angles, all the red angles would be 64.
You always have to find the center too?
No. Well, I mean, you could though.
9 is 64 because it's a right angle. Or?
Yeah, because this corner is a right angle, right?
Uh-huh.
So this would make this 26. And because these are parallelograms, then I know that alternate interior angles, because they're parallel, alternate interior angles gives me these two angles. And then I can use alternate interior and just keep moving around and.
But that P1 is what, 26 too? Right.
Yeah, all the blue ones are going to be 26, and all the red ones.
It's going to be 64.
Mm-hmm. Let me get those red stars out of the way. That's probably confusing. Yeah, so all the blue will be 26, and the reds will be 64. And then if you wanted, you could then use that information to find out the center angles, because these are both 64, and the whole triangle is 180. So, or these are both 26, and the whole triangle is 180. So you could find out the middle if you needed to. We're not doing that right now, but it is possible. All right. Quadrilateral JKLM is a rectangle. Draw a rectangle. Name it. We want to name it. You start in one corner and then you just go in order clockwise around in the same order they give you the numbers. That way you know you've labeled it correctly. The measure of angle KJL. Okay, so I need to do a diagonal because I want to get KJL, that's this angle right here, is 2x plus 4. And
drawing is terrible like mine.
JLK, it doesn't matter if it's terrible. JLK, so that's this angle right here, is 7x plus 5. And I want to find x. Now I know that this blue angle is the same as this blue angle here. And my red and my blue are going to add up to 90 because it's a rectangle. So I'm going to add these two things together to make 90. Okay, so I get 9x plus 9 equals 90. So 9x equals 81. So x is 9. Okay. Now, we're using the same rectangle. I'll just redraw it though. And if I have a new letter introduced, P, that usually represents the point where the two diagonals are crossing. So JP is 3y minus 5, and MK is 5x plus 1. Sorry, that's the whole length. This whole length is 5x plus 1. I want to know what does JP, or sorry, what does y equal?
What's that, 3y minus 5?
Yeah, here's 3y minus 5, and then this whole thing is 5y plus 1. Not written very well, sorry. Well, the two diagonals are going to be congruent. And it's parallelogram, so the diagonals bisect each other. So this 3y minus 5, and this is also going to be 3y minus 5.
If we make it 6y.
Yeah, so 2 of these equals 1 of those.
So 6y minus 10.
Okay. So you're going to subtract the 5y from both sides.
Actually, y equals 11.
So y minus 10 equals 1. So add 10 to both sides. And you get y equals 11. Theorem
Was it done?
6.1. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So, regular parallelogram, right? We have diagonals, and I'll just call this A, B, C, D.
ACDC?
No, A, B, C, D. In a regular parallelogram,
Actually, no.
AP is congruent to PC, and DP is congruent to PB. But DB and AC are not necessarily congruent. Okay, so
AC or never could
not never.
Oh man, I was talking about Dr. Pepper.
No, sorry, is not necessarily congruent to DB. Okay, so it can be congruent, but it's not necessarily congruent. We don't know anything about these two lengths in relationship to each other. But if we know they are congruent, so
exterminate.
W, X, Y, Z. So if WY is congruent to XZ, it's a rectangle. Okay. So this is one of the ways you can tell if something is a rectangle or not. If your diagonals are congruent, you are a rectangle. Has vertices at 5, negative 5, 3, 1, negative 1, negative 1, negative 4, and all that stuff. So we're a lot more negative than we are positive, so I'm going to shift a little to the right.
This is me right now.
And I'm going to decide if this is a rectangle. So I'm going to go negative 5, and then positive 3. And then I'm going to go 1, negative 1, negative 1, negative 4.
Miss, you should start putting the graphs in there. I mean the cross through it for us. They're a lot better.
1, 2, 3, 4, 5, 6, 7, 8, 9. Ah. Oh, that's right. I messed that up. That's supposed to be a 0. Yeah, that's a typo. Sorry. Change that to a 0. 1, 2, 3, 4, 5, 6, 7.
It's about to say.
Yeah, well, it wouldn't have been a rectangle at all, or even a parallelogram or anything. Okay, now to tell if this is a rectangle or not, I need to know, let's see, this was P, Q, R, and S. I need to know that PS is congruent to QR, and I need to know that PQ is congruent to SR. Now, why am I drawing parallel? Congruent. I said congruent, I drew parallel. Congruent. Okay, so I need to know that their lengths are the same. So I can use the distance formula for that. And the distance formula, x1
Here we go again, we're using the same thing.
minus x2 squared plus y1 minus y2 squared.
I got this, which one here, this distance formula, I got it down. This one.
Okay, so the distance of PS is -5 plus 7 squared plus 3 minus 0 squared. And when I work that out, I'm going to get the square root of 13. That's PS. And then the distance of QR, I have 1 plus 1 squared plus negative 1 plus 4 squared, square root of 13. Any questions as to how I'm plugging these in?
Yes, just pause it.
All right, so I've got that PS and QR are both going to be the square root of 13. So those are congruent. So now I need to do PQ and SR. So the distance for PQ is going to be,
You said PQ and you put what? Oh, the D means distance.
yeah, distance. Negative 5 minus 1 squared plus 3 plus 1 squared. So I'm going to end up with the square root of 52. Because that gives me negative 6, so that's 36. Plus 16, 52. So this is the square root of 52. And then the distance of SR is going to give me negative 7 plus 1 squared plus 0 plus 4 squared, which again is 36 and 16, so it's the square root of 52. Okay, so I know I'm a parallelogram now, for sure, because my opposite sides are congruent. So what all this told me up here is that I am a parallelogram.
It's a lot of work just to find out.
Now I need to know if my angles are 90 degrees. How do I find that out? Perpendicular slopes. Or I can find out if my diagonals are congruent. So, because parallelograms have opposite sides congruent, but if you're a rectangle, and I'm trying to find out if it's a rectangle, to be special, to be a rectangle, your angles are 90 degrees or your diagonals are congruent. So we have to decide, do we want to do slope of 2 of the lines and find out if they're perpendicular? Or do we want to do diagonal distance and find out if those are congruent?
Remember you said we can leave it over today.
No,
Yeah, you did.
Yeah, you do.
Yeah, I wrote it down.
10 minutes.
do you want to find the 2 slopes and see if they're perpendicular, or do you want to find the 2 distances and see if they're congruent?
What is harder to do?
They're both math.
No, I was gonna say like whatever's harder, we should do that one.
No, not the distance.
Distance is just like this.
I say slope then.
Okay, so slope. So we want 2 lines. We need to find out one angle is perpendicular, so it's 90 degrees. So I'll do PS and SR. So the slope of PS, remember it's y2 minus y1, so I'm going to do 0 minus 3, and then negative 7 minus 5. So I get negative 3 over negative 12, so that's 1/4. Oh, sorry, I lied. Negative 7 plus 5. Because it's minus a negative. So that's, so 0 minus 3 is good. Negative 7 plus 5, so it's negative 2, so it's 3/2. Okay, and then the slope of SR. Alright, so SR, I'm going to have 0 plus 4 over negative 7 plus 1. So I've got 4 over negative 6, which is negative 2/3. 3/2 and negative 2/3 are perpendicular. Negative 7 plus 1, yeah.
Oh, you
Okay.
see, this is way too much.
So they are perpendicular, which means that this is a 90-degree angle. Well, if this is a 90-degree angle, so is that. And so is that. And so is that. So we are a rectangle. All right, a rhombus is a parallelogram with 4 congruent sides. So diamonds, or a square, but it's squishy to the side. So all 4 sides are the same length. And if a parallelogram is a rhombus, its diagonals are perpendicular. So if A, B, C, D, so if A, B, C, D is a rhombus, that means all 4 sides are the same length. And if it's a rhombus, the diagonals are going to be perpendicular to each other. Also, if it's a rhombus, the diagonals bisect the angles. So okay, so PQRS. And I'm just going to number the angles to make things easier. Okay, if it's a rhombus, then angle 5 is congruent to angle 6, is congruent to angle 7, is congruent to angle 8. And angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. It's a terrible congruent, but you get the idea. So the angles are bisected by the diagonals. And we also know it's a parallelogram, so we know that the diagonals bisect each other. And because it's a rhombus, the diagonals will also be congruent. Okay, I have a rhombus, and it's FG, HJ. And the diagonals intersect at K. So there are 2 diagonals that intersect at K. And I'm going to find the measure of angle. Okay, so the measure of angle FJH. So FJH. That's this entire angle. Is 82. And I want to find the measure of KH. J, sorry, that's a typo. HJ. So I'm looking for this angle right here. So, well, there's no L. All right, so KHJ. If J is 82, what's G? All of G?
It's also 82 as well.
It's going to also be 82. So I've got 82.
360 minus 160.
Hold on. Okay, so 82 times 2 is 164. So I'm going to do 360 minus 164. So 360 minus 160 is 200, minus 4 is 196. So both of all of angle F and all of angle H will equal 196, so I need to divide that by 2. get 98.
And that 82?
Divided by 2.
What?
98 divided by 2.
So this whole thing
4.
is 98. But remember, we just want the green part, that's this half. So I do 98 divided by 2, and I get 49 degrees.
Because I was doing that division, I go around between 2 dots. It's still a good song.
What?
Instead of double.
Okay, if GH is x plus 9, and JH is 5x minus 2, I'm a rhombus, which means what about my sides? They're equal.
What? Oh, that's gonna blow up.
Subtract x from both sides. Add 2 to both sides. So I get 11 is equal to 4x. I'm going to divide both sides by 4, and x is going to be 11 fourths. Or
Really fast.
2.7.
This is why I don't take concepts twice. If I take notes, I'm screwed, because then I'm distracted.
5.
I can't watch what's going on. Yes?
Okay, so I set the two sides equal to each other and solve for x. You can leave it as a fraction if you want, or if you like to do the division, you can do the division and you'll get 2.75. Either of those answers is fine. I don't care. And a square is a special rhombus.
Measure one.
Yes, it is also a rectangle.
But a rectangle is not this.
Okay.
Also parallel.
It is a rhombus with 90-degree angles. So a square is a so a square is a quadrilateral that is a parallelogram that is a rectangle that is a rhombus.
And it's also a square.
And it's also a square. Okay, so quadrilateral, any four-sided figure. Just, it doesn't matter what it looks like, it just has four sides, right? So it can be all kinds of funky. This is a trapezoid. You know, just, there's anything that has four sides. This is a side and then that's a side. Okay. Parallelograms have opposite sides. Are parallel and congruent. So they're quadrilaterals, but they have special properties. Rectangles are parallelograms with 90-degree angles. Rhombi are parallelograms with congruent sides. And a square is everything. Okay, so every square is a rectangle, but not every rectangle is a square.
no rectangles.
No, some rectangles are squares.
That just makes it a square.
Right, but it's still a rectangle, and it's also still a parallelogram, and it's also still a quadrilateral. So every square is a rectangle, a parallelogram, and a quadrilateral, but it's also a rhombus, and a parallelogram, and a quadrilateral. So everything fits inside each other, except the square is like at the center of everythingness.
You say before.
Okay, so how you can, conditions, I spelled conditions wrong, there should be an O in it, sorry. Okay, if you have a parallelogram and the diagonals are perpendicular, it's a rhombus. Rhombus is the only time the, well, square, but a square is a rhombus. So if you have diagonals that are perpendicular, you have a rhombus. If you have diagonals that bisect the opposite angles, it's also a rhombus. And then if your consecutive sides of a parallelogram are congruent, because opposite sides we already know they're congruent, but if consecutive sides are also congruent, you have a rhombus. And then if you're both a rectangle and a rhombus, you're a square.
Is that it, man?
Okay,